So let's talk about matter. As we said in chapter 1, matter is at the heart of chemistry. Chemistry is basically the study of matter and the changes it undergo. And in chemistry, we try to understand basically at the microscopic level how matter behaves so that we can use that as a model for predicting other things about reactions. So, what is matter? Matter is anything that has mass and volume. So it is the stuff that makes up material. Now, one important aspect are what we call properties. Properties of substances are basically those defining characteristics of a substance, right? So we're talking about things like taste and smell, whether or not it has a color, what color it is, and so on. Density, um, combustion, stuff like that. Things that a substance may display, which basically identifies it. So, as stated here, each substance has a set of properties that are unique to that substance and therefore makes it very identifiable. So, there are two types of properties that you need to be concerned with. All properties fall under one of these two categories. They're either physical properties or chemical properties. So, for physical properties, we're talking about those observable characteristics that we can basically observe without changing the composition of the substance. So, some examples are listed here. And as you can see, these properties themselves can be subdivided into two characteristics or two other properties or characteristics. You have taste and color, which are qualitative as well as physical state. But then you have things like melting point and boiling point and densities and so on, which are quantitative. So there are two types of physical properties. Basically, those that are qualitative, which you can simply observe, and those that are quantitative, which you can measure. So just to give you an example of what we're talking about, we're going to look at these physical properties of chlorine. So it says here chlorine is 2.4 times heavier than air. It has a yellowish green color. Its odor is disagreeable. And the melting point is 101 degrees Celsius. And the boiling point is, actually, the melting point is minus 101 degrees Celsius. And the boiling point is minus 34.6 degrees Celsius. So these are just some examples of the physical properties of chlorine. The last two, of course, are the ones that you can measure, and therefore they are quantitative. Okay, so we talked about physical properties. What about chemical properties? Well, the chemical property of a substance is one that, when observed, involves a chemical reaction or the substance actually being converted into new material. So again, to illustrate what we mean by chemical properties, we're going back to the chlorine that we saw before, and what you see here are a list of chemical properties of chlorine. The fact that it will not burn in oxygen, that it will support the combustion of certain other substances. It can be used as a bleaching agent, and it can be used as a water disinfectant. And finally, it can combine with sodium to form sodium chloride. So these are all examples of chemical properties. So just to summarize, physical properties are those properties that, when observed, does not involve a change in the composition of the substance, while a chemical property, when observed, involves a change in the composition of the substance. So what you see here on the screen is a short list of different substances and their physical and chemical properties. Well, actually, physical properties only. Um, so just to highlight the example of, let's say, sugar, it is white, odorless, has a sweet taste, is a solid under normal room temperature conditions. The melting point is not given, and the boiling point is shown here. Actually, the boiling point is not even given, it shows the temperature at which it decomposes. So these are just basically some description of the physical properties of these four different substances. Okay, now if you understand what we mean by physical and chemical properties, then you should have no problem understand what we mean by physical and chemical changes. So a physical change is one where basically you have a change, but the composition of the substance itself does not change, right? Um, so an example would be tearing of paper. Another example would be the change of ice into water. Another example is the change of water into steam. And the final one here is heating platinum wire. So each of these are physical changes, right? They are changes that are taking place, but the substance itself remains the same. So changing of ice into water does not change the fundamental composition of the substance. It's still H2O, even though it may have converted from the solid state to the liquid state. All right. So in each of these examples, you do not have the creation of new substances. So that's basically what typifies a physical change. Chemical changes, in chemical changes, what you have is new substances that are created from the original material. All right. So what you'll find is that a new substance that is formed will have completely different properties from the substance that you started off from. An example of this is when you heat copper wire in a Bunsen burner, then what happens is that the copper reacts with the oxygen to form a new compound known as copper 2 oxide. So this is an example of a chemical change because you're starting with one substance, copper, and you end up with a new substance, which in this case is copper 2 oxide, right? And we can tell that the two substances are different. Copper 2 oxide is a black substance. Copper itself, the metal, is a brownish red metal, right? So that alone tells you that a chemical change has taken place. Another thing that has told you that a chemical change takes place is that the composition of copper is, of course, 100% copper, but the composition of the new substance, copper 2 oxide, is 79.94% copper. The rest of it is oxygen. All right. So that's what happens when you have a chemical change. A new substance is formed. So what this is showing you is basically the composition of copper 2 oxide. It actually is made up of ions, copper 2 plus ions and oxide ions. We're going to later on talk about how ions are formed and how ionic compounds are formed. Copper 2 oxide is an example of that type of compound. Okay, and one difference between this and the original starting materials is that the original starting materials do not contain any of these ions. So that again underscores the fact that a new substance is being formed from the original reactants, right? And as a result, a chemical change has occurred. Okay, now in chemistry, we oftentimes use a shorthand way of representing a chemical reaction. So instead of writing out the reaction in words, we use what are known as chemical equations. And in a chemical equation, basically you start off with your reactants. So you write down the formula for your reactants on the left side. You have an arrow, and then you have the formula for the substances on the right side, which are the products. And this is basically what a chemical equation is about. Now later on, we're going to learn how to write down a chemical equation to accurately represent the actual change that is taking place. So this is just a bit of an introduction to what a chemical equation is all about. So that's basically what makes up a chemical equation. Now, sometimes you might have some other information that is printed above or below the arrow to indicate the conditions of the reaction. So for example, in this case, we see electrical energy. Basically, what this is telling you is that an electric current is needed to basically split up water into its constituent elements, hydrogen and oxygen. All right, so chemical symbols can be used in a chemical equation. So that's what you see here. This is basically the symbols that are used to indicate, in this particular case, that water is being split up or electrolyzed. That's a term that is used when an electric current is used to split up a substance. So water is undergoing electrolysis to form hydrogen and oxygen. All right. Here's another example of a chemical equation. In this case, in fact, this is the previous example we looked at, the reaction between copper and oxygen when heated to form copper 2 oxide. So copper and oxygen would be the reactants in this case. Now this small triangle here, we use that to represent heat. All right. Sometimes you'll see the actual word heat being written above or below the arrow, but you can also use this symbol here. And the product, of course, would be the copper 2 oxide. So this is another example of a chemical equation that you see here, 2Cu plus O2 to give 2CuO. All right. As I said before, later on we're going to learn how to actually write down an equation to accurately represent what is happening in a chemical reaction. So, to end this section here, we're just going to look at this table, which shows you some examples of different changes, chemical and physical, and it tells you the type of changes and the observations, right? And typically, in a chemical change, you look for a couple of things, right? If you see a change in color, right? So let's say, for example, you mix something blue with something red and you get something black, all right? Well, that's obviously a chemical change in that case. If you see a gas being formed spontaneously, that usually indicates a chemical change, such as burning sulfur in air to produce sulfur dioxide, which is a gas, all right? If you see a temperature change, or if you feel a temperature change, right? If you observe a temperature change, either decrease or increase in temperature, then usually that indicates a chemical change. So those are the things that you look for. If you see a solid being formed when you mix two aqueous solutions, I don't see an example of it here, but that's also another example of a chemical change. So those are the things you look for when we are talking about chemical changes. Physical changes, basically, you don't see those things that I just mentioned. You might see, a gas being formed, but of course, that is when the substance evaporates, for example, when you heat it. But apart from that, you don't see much of a change otherwise because it's not a chemical reaction. There may be a change in state where it goes from solid to liquid and so on. Okay, so the next video I'm going to post up will be dealing with the law of conservation of mass. Until next time.